Hi class, so today we're talking about the distributive property. I'm going to explain what the property is with regular numbers first using an example, and then we'll try to apply it to polynomials after. Okay, so let's say we have these special envelopes that some relatives like to give you. Okay, just making up a story here. So you have these special envelopes, and inside of these envelopes, they put money in. They put a $10 bill in, and they also put a $5 bill in. And then they prepare these envelopes and they give them to their relatives such as yourself. Okay, so if you get one of these envelopes, you obviously get $15. But let's say your relatives are feeling very generous and they decide to give you many of these envelopes. So let's just see how many I can draw in here. Maybe we'll just go with 5. Okay, let's say they give you 5 of these exact same envelopes. They all have a $10 bill and a $5 bill inside of them. Then, how much money will you have in total? So there's two ways we can approach this. Approach 1. We can know how much is in each envelope and then multiply it by how many envelopes we have. Okay, so number of envelopes times value of each envelope. Now, if we write this out with mathematical symbols, it will look like this. It'll look like 5 envelopes times, in brackets, $10 plus $5. Okay, so 5 times brackets $10 plus $5. And you can add together $10 and $5. That'll give you $15. So the amount of money you have will be 5 times $15, and that ends up equaling $75. Okay, so that's one approach, and that's strictly following BEDMAS, the order of operations. We calculate the brackets first and then do the multiplication after. However, there is a second approach to this. So I'll call it approach 2. And that is actually to figure out the number of envelopes. We're going to multiply that by how many $10 bills there are, and then also multiply it by how many $5 bills there are. So the number of $10 bills and the number of $5 bills. But we're going to do that separately before adding together. Sorry, we're going to do that separately and then add them together afterwards. So it's going to look like this. 5 envelopes times a $10 bill and a $5 bill in each envelope, just as before. But to add up this money this time, I'm going to do it like this. I'm going to say 5 times $10. That represents 5 $10 bills. And then I'm going to add it to 5 times $5 because I have 5 $5 bills. So I've got 5 $10 bills and I've got 5 $5 bills. I'm going to find out how much those are each worth. So 5 $10 bills is $50. And then 5 $5 bills is $25. And when I add $50 and $25, I get $75, just like I did last time. So there's a difference in approaches here. However, I want you to know that they both start off looking like this, what I'm highlighting here in yellow. They both start off looking like 5 times brackets 10 plus 5. So method 1 is to add what's inside the brackets first. But the second method is different. Instead of adding 10 and 5 first, I actually multiply each item by 5. So this I'm going to call multiply each term in the brackets by the term outside. And they both lead to the same answer of $75. So the second method I've laid out there has a name, and that's called the distributive property, or using the distributive property. So I'm going to get into that on the next slide. Examples. Okay, the distributive property is typically written as follows. If you have numbers added inside of brackets, I will say b plus c as just any general numbers. And then you multiply the entire bracket by another number outside, which I'm going to call a. This will equal to multiplying a with b, multiplying a with c, and then adding the two results together. Okay, so it is saying that instead of adding b and c in the brackets first, you can actually multiply them each by a first and then add them together afterwards. So we saw that as an example with regular numbers like 10 and $5. We're going to try to apply this to algebra now, so variables. So you may see a question like this. It'll say simplify, and then they'll have a term multiplied by a brackets. And inside the brackets, you can have a couple of terms. So I'll say 6x plus 7. Okay, when it asks you to simplify this, what it means is they want you to apply the distributive property. They want you to multiply 3 by 6x, and they also want you to multiply 3 by positive 7. So the first part, 3 times 6x, that's 3 times 6, which is 18, times x to make 18x. You may have to go back to multiplying monomials to remember that. There's a lesson called multiplying monomials. And now we're also going to do 3 times positive 7, and that makes positive 21. And that would be your answer. That is the simplified version of the above. So we call it the distributive property because in this case, basically multiplying by 3, or that 3 gets distributed to every term inside the brackets. Sometimes there's more than 2 terms inside the brackets, such as follows. So another example. Okay, 4 times brackets x minus 2y plus 3. So now there's 3 terms inside the bracket. Note, you cannot really use BEDMAS. If you look and you try to just add or subtract inside the bracket, you can't because they're not like terms. There's an x term, there's a y term, and there's a constant term. So the only way to simplify this is to apply the distributive property. So the first part would be to do 4 times x. That will give you simply 4x. Because the x is like a 1x, so you're doing 4 times 1x. Then the second thing to do would be to 4 times negative 2y. You have to consider the sign that's attached to each term. 4 times negative 2y, that will be negative 8y. A positive times a negative is a negative. And then the third thing to do is 4 times positive 3. 4 times positive 3 is positive 12. And this would be your answer for the second example. So that's the distributive property. We'll do a lot more. So sometimes they're written kind of the opposite way. So for instance, the number that's being multiplied to the entire brackets may be on the right side instead of the left side. And you would actually do the same thing. You would take that -2 and you would multiply it with every term inside the bracket. So the first thing to do here would be -2 multiplied by 6a. So that will give you -12a. You know, positive times a negative is a negative. And then you would do -2 multiplied by positive b. Again, a positive times a negative is a negative, and it will be 2b. You have to think of the b as 1b. So 1 times -2 is -2. And finally, we would multiply the -2 with -7c. So now we have a negative times a negative, which is a positive, and it'll be 14. 7 times 2 is 14, and times c. So that would be the answer to the third example. Now we also don't want to forget our exponent laws. So here will be yet another example. Okay, 2x squared times, in brackets, 4x squared plus x minus 3. So again, we will apply the distributive property. So 2x squared times times 4x squared. So we have to go back to multiplying monomials. So first we do 2 times 4 to give us 8. And then we think about what's x squared times x squared. Okay, so I'll underline that, x squared times x squared. And you have to remember that makes x to the 4th. When you're multiplying powers with the same base, you add the exponents. The second thing to do is 2x squared times positive x. So we can think of positive x as positive 1x. So then we multiply. 2 times 1 is 2. And then x squared times x gives you x cubed. The exponent laws. This is 1x to the exponent 1. We add the exponents when multiplying powers with the same base. Finally, we will have 2x squared times -3. So the number part is 2 times -3, making -6. And then the letter part will simply be x squared, coming from the 2x squared. Okay, so there's an example where you also have to apply exponent laws. It can be a little more complicated as follows. Okay, so we have -x times brackets 6x plus 2y minus 4. So same as above, just got to be careful about the letters and the signs. So the first multiplication, -x times positive 6x. So the -x, we want to think of it as -1x. So -1 times positive 6 makes -6. And then for the letter part, it's x times x. X times x is x squared. Okay, second term, we'll do negative 1x times positive 2x. So the number part, negative 1 times positive 2 is negative 2. Now how about the letter part? What's x times y? What is x times y? Well, x times y is actually just written as xy, just like that. You don't make it, it's not x squared, it's not y squared, because they're different letters. All you can really do is write xy. Okay, and now the third term, negative x times negative 4. So the number part is negative 1 times negative 4. That makes positive 4. And the letter part is just x. Okay, so there's the answer to that one. And then we can have even more complex examples where we combine this with collecting like terms from a couple lessons ago. Okay, so let me show you how that looks like. You may have a question like this. So this is a long example, and it's basically throwing all the skills we've learned from polynomials all at you at once. But at least this example only sticks with one letter, x. Okay, so a step I've been skipping or not talking about actually is looking inside of the brackets to see if anything can be simplified just inside an individual brackets. So looking at what I just underlined, are there any like terms there to simplify? And the answer is no. You have an x squared term, an x term, and a constant term. So none of those are like terms. You can't simplify that. What about the second brackets? Any like terms there? And I see the same thing. There are no like terms there. So don't neglect that step, because sometimes there is a simplification you can do. But if there's not, you can just kind of look at it mentally like I just did. Okay, so now if we can't simplify inside the brackets, we can apply the distributive property. So for the first set, I'll have 3x times 4x squared. So 3 times 4 is 12. And then x times x squared is x cubed to add the exponents. Then 3x times negative 1x. 3x times negative 1x. The number part will be negative 3. The letter part will be x squared. X times x is x squared. Followed by 3x times positive 2. So the number part, 3 times 2 is 6. And the letter part is simply x. Okay, so that is the first bracket with the distributive property applied to it. The second bracket, we do the same. Now be careful, the 2 has a minus sign in front of it. It is negative. So you have to think negative 2 times positive 5x. Negative 2 times positive 5x. So the number part will be negative 10. And the letter part will be x squared. Sorry, it's not x, but x squared. Next, negative 2 times positive 3x. So the number part is negative 2 times positive 3, which is negative 6. And the letter part is x. And finally, negative 2 times positive 2. Negative 2 times positive 2 is negative 4. So that's the first line, and that's applying the distributive property twice to the two sets of brackets. Now we ask, can we continue simplifying, meaning collecting like terms? You will notice that there are some like terms here. So we have one more step to collect them up. The first term is 12x cubed. So I look down the line, and ask, are there any more x cubes? And I don't see any, so that will be just by itself. Okay, the next term, I'll use a different color, is negative 3x squared. So I look down the line and ask, are there any more x squared terms? And I see one, negative 10x squared. So I'll underline those the same color. The next term is positive 6x, and I look down the line and ask, are there any more x terms? And I do see one. I see a negative 6x. And that leaves one term left over by itself, negative 4. That's a constant term. Okay, so I will rearrange these into so that the same colors are beside each other. So 12x cubed, that's yellow. That one's the only yellow there. Then I'll put the greens together, minus 3x squared, and then minus 10x squared. Okay, those were the green ones from above. Then I'll put the blue ones together, positive 6x, minus 6x. And then I'll write the red one last, minus 4. My preference is to write them in descending order of power. So I typically like to write for this one, the x cubes first, and then the x squareds, and then the x's, and then the constants. So getting powers going from higher to lower. Okay, so the final line, I'll write 12x cubed, that's the yellow term. But the green one, I have to think of my integers, negative 3 minus 10. Negative 3 minus 10 drops down to negative 13 x squareds. Then the blue ones, positive 6x minus 6x. That actually makes 0. That actually makes 0. So when it makes 0, you don't have to write anything down. You just leave it out. And then the final term is minus 4. Okay, so that is my answer for this one here. And yeah, now you get to practice this a whole bunch.